You know that moment when your radio starts crackling or your Wi-Fi just drops for no reason? What's the first thing you blame? The microwave, probably, or some faulty charger. We spend so much time hunting down all the noise we create, what we call radio frequency interference, or RFI. But what if the biggest source of static is something you can't unplug? Something that's been broadcasting since the dawn of time? Now, just so you know, this is part 4 of our deep dive into a really detailed report on the top 30 sources of radio frequency interference IRT. It comes from the experts over at RFI Detectives, who are part of Virtualization Options LLC. In this part, we're going way beyond our gadgets and looking at the natural world itself. So that really brings us to the big question for today. We're all surrounded by our own electronic chaos, for sure. But is that static in your signal really from your smart fridge? Or could it actually be an echo from a thunderstorm on the other side of the planet? Or maybe even a whisper from the very beginning of the universe?
Okay, so here's how we're going to tackle this. First, we'll get our heads around this idea of a universe that's full of invisible static. Then we'll zoom in on interference coming from right here in our atmosphere. After that, we're going to listen for echoes from deep space. And finally, we'll connect all the dots and see why understanding this natural noise is absolutely crucial.
All right, first up, nature's invisible static. You know, we tend to think of space as silent, but electromagnetically, it's anything but. The universe is constantly broadcasting, creating this background hum of noise that was here long before we ever built our first radio.
And this is a really helpful way to break it all down. The report from RFI Detectives basically sorts all this natural noise into 3 main buckets. You've got atmospheric, which is stuff happening right here on Earth. Then there's space weather, which is all about what our sun is up to. And finally, you have cosmic noise, coming from our galaxy and, well, everywhere else. This is going to be our map for today.
Okay, let's dive into that first category. We're going to start close to home, with all the interference that's cooked up right inside our own planet's atmosphere. I mean, just think about the incredible power of a lightning strike, right? Every single bolt is basically a giant natural radio transmitter, just blasting out energy across a huge range of frequencies. That's that classic crackle you hear on an AM radio during a storm. But it's not just the big stuff. There's also this constant, low-level static from atmospheric charges. And even the northern and southern lights, the auroras, they generate their own faint radio hiss.
All right, now we're going to zoom out, way out. We're leaving the familiar noises of our own planet behind and tuning into the ancient, deep sounds of the cosmos itself.
This line from the source report, just wow, it really captures the mind-bending scale of what we're talking about. This isn't just random noise, it's a fossil record. It is literally the sound of the universe's creation, and it's still echoing all around us right now.
So, what exactly is this cosmic microwave background, this CMB? The best way to think about it is like the leftover heat from a massive explosion, but on a universal scale. It's not coming from a star or a galaxy over there. Nope, it is everywhere. It's the faint, uniform afterglow of the Big Bang itself, filling every single inch of space.
So under this cosmic umbrella, you have that super faint but all-pervasive CMB. But you also have something called galactic radio noise. And that's pretty much what it sounds like. It's the combined radio energy from all the stars, black holes, and gas clouds inside our own Milky Way galaxy.
But here's the thing. We don't have to look billions of light years away to find really powerful sources of RFI. The star right in our own backyard, our sun, is one of the most powerful and disruptive sources we have to deal with. And that brings us to space weather.
Yeah, our sun is anything but quiet. It's constantly bubbling and erupting. The most dramatic events are solar flares. These are violent explosions that launch massive bursts of radiation right at us. And these are not subtle. They can mess with satellites, GPS, even the power grid down here on Earth. And then you have the constant solar wind, a stream of particles that smacks into our magnetic field and creates those beautiful auroras, which, like we said, also produce radio noise.
So we've got thunderstorms, the sun, the Big Bang, all creating this constant radio static. Okay, so what? Why does this actually matter? Well, this brings us to what might be the most important point of all.
And this slide just lays it out perfectly. Look, if your interference is coming from a cheap phone charger, you can track it down and get rid of it. You can shield a cable. You can add a filter. But you can't put a filter on a solar flare. You can't unplug a thunderstorm. You can't just switch off the Big Bang.
This reality leads to this super important concept in radio engineering, the irreducible noise floor. Think of it as the absolute minimum level of background static that's always there, thanks to nature. Any signal we want to send, whether it's for your 5G phone or a deep space probe, it has to be strong enough to be heard above this constant universal noise.
So here's the real takeaway. The whole game has to change. When it comes to natural RFI, it's not about trying to eliminate the noise. You can't. It's about building resilience. It's about designing smarter systems with receivers that are sensitive enough and coding that's clever enough to pull a clean signal out of all that cosmic chaos.
And that kind of leaves us with this one final thought. Every time we build a new wireless network or launch a new satellite, we're essentially trying to have a very quiet, very precise conversation in a room that is incredibly loud. The challenge isn't just about talking louder, it's about getting better at listening. So the big question is, as our entire world becomes more wireless, how do we design for a universe that never, ever stops talking?